Welcome to Casual Conversations, brought to you by Momentum Ministries, helping you attain, maintain, and regain spiritual momentum. Let's join the conversation with Scott Wade, president of Momentum Ministries.
Great to have you on Casual Conversations today. Thank you for tuning in. I am Scott Wade. I'm your host today, president of Momentum Ministries and an evangelist in the Church of the Nazarene. Well, we have back on with us this week Dr. Bruce Evans from Huntington. Used to be at Huntington University, now Professor Emeritus from Huntington University of Biology. And so it's great to have you back, Bruce.
Thank you. Yeah, we're kind of sunny and warm up here in Huntington. So
yeah, last time when we recorded, it was quite different. I think there were maybe 30 or 40 degrees difference between South Carolina and
I will take what we got today.
Yeah, I was telling you before we came on that it'd be great to have some 70 degrees, but we're not too much over that. 80 degrees, not bad. So anyway, we're going to continue with our conversation from last week when we were talking about information and just some of the founding principles, I guess you'd say, of creation. And we're going to talk about in particular, some biological things, I believe. But before we get going, Dr. Evans, I just wanted to talk to you or tell you a story that I heard a long, long time ago. It may be familiar to you, but there was 3 bears that lived in the woods.
I know that one.
You know that one? Well,
yeah.
One day they made some porridge, and they went out and the porridge was too hot to eat, so they put it in the bowls and put it on the table. They went out for a walk, and while they were gone, a little girl came by named Goldilocks. You hanging with me here?
I'm right there.
Okay, good. Well, Goldilocks went in. She was a curious little girl. She went in and she saw the porridge sitting there and decided she was hungry. She tried the first bowl of porridge. It was a great big bowl for Papa Bear, and she said, "Oh, this is too hot. I can't eat this." She tried the second bowl of porridge and said, "This is too cold. I can't eat this either." And then she came to the third bowl, and she tried that, and she said, "This is just right." And she ate it all down. And then, of course, the story goes on. And with the other things, I think, is a chair and sleeping in the bed, and the bears came back. But that phrase, "and it was just right," is what I want to focus on today, because I believe, as you shared with me some of the thoughts that you're going to be sharing today, you talked about how conditions were just right for life on Earth. And so I'm just going to kind of throw it open from there. And maybe you can talk a little bit about the age of the Earth and a few things. But I really want to get into those just right conditions for life on Earth. So, Dr. Bruce Evans.
Yeah, there's so many things to talk about there. So, well, we've only got so much time. But, some people would call that the Goldilocks effect. And if you look, there are a couple of ways you could look at that. The Goldilocks effect, you can say Venus is too close to the sun for life. Mars is too far away from the sun. So we sit in this little, what we call the circumstellar habitable zone, or the Goldilocks zone, where we can, and there are many other things that go into that, but that's part of that. We also are in the galaxy in a galactic habitable zone. We are not so close to the center of the galaxy or so far away from the center of the galaxy that it's not compatible for life. So our galaxy is in our solar system is in the right part of the galaxy. The Earth is in the right part of the solar system, and that's just a start. And we could call that the Goldilocks zone if you like, and some people do. It helps people make that link.
Uh-huh.
So other kinds of things, some of these are aspects of our life on Earth, such as we have an iron core, which helps us to create this electromagnetic field around the Earth and helps to
You're not talking about this iron core here.
Oh, not that one. Maybe this one, but
yeah.
And it helps us to deflect cosmic rays and protect the life on Earth. things like our moon. Our moon is very large. Our moon helps us to stabilize our orbit. Our moon helps us to produce tides, which help to recycle nutrients and other aspects of geology on the Earth. And there are so many of those kinds of things. We have the right amount of oxygen so that we can have life, but not too much oxygen so that we have spontaneous combustion all the time. We have radioactivity. Radioactivity helps to drive the movements of tectonic plates, which also helps to recycle things like calcium. And so there are a number of those things at that aspect. There's a website called Reasons to Believe, run by a fellow named Hugh Ross. He works with a guy named Fuzz Rana, and they have put together this website, lots of research. They are good at looking at these parameters. And so here are just some of those that they have listed. I went onto a website from there, and they've produced books on this, and they've cited the scientific literature. So it's not just throwing ideas out there. They have evidence to suggest that these things are really true. So these are just some of those things. The strength of the strong nuclear force, the weak nuclear force, the gravitational force, the electromagnetic force. Those are the four fundamental forces of this universe as we understand them. If they were changed in minute degrees, we would not be able to make atoms. We might not have enough neutrons or enough protons. We would not have carbon if it were not for a very specific resonance of carbon. And I'm not going to get into what that is, but a very specific and unexpected resonance of carbon, which allowed it to be made when a lot of the physics says it shouldn't be made. But here we are. And those are some of those aspects. He lists all sorts of things. Which,
tell me again, I'm fascinated by that, the four forces.
Yeah, the four fundamental forces as we understand them of the universe. There's a strong nuclear force, a weak nuclear force, electromagnetic force, which we probably understand pretty well of charges, and then there's gravity. And in fact, gravity is weaker than the electromagnetic force by a factor of 10 to the 40th power.
Oh,
and if it were any different, well, if it were even slightly different from that, we would not have life in this universe. And I understand that in part, but I'm no physicist. I read things. I don't have enough background to say fundamentally why that's so. I understand a little bit, but not enough to. You go to his site and look at the research articles. Maybe
so I'm going to take you down a little bunny trail here. Okay. I was reading recently about the shift in the Earth's magnetic true north, or whatever you call it.
It moves.
And somehow that if it hadn't been for that, for this magnetic, I didn't go into the article because I wouldn't have understood it as well as you could explain it. But if it hadn't been for how that was all situated, how that magnetic force works, we couldn't have life on Earth. Am I saying that right, you think?
You might be, but I don't know a whole lot about
that.
That's one of those things that certainly I could go read about it, but I don't know enough to speak intelligently about that one.
But so the electromagnetic force is stronger than gravity.
Much, much stronger. Although we sit here and we experience gravity as a strong force, but related to the force of the the magnitude of the electromagnetic force, it's very, very small. But it's enough to keep us on this planet. If our planet were much larger, it might take the land masses and pull them closer to the center of the Earth, and therefore we would see just mostly water. It would also make it more difficult for us to hold our bodies up. And if the Earth were smaller, we'd probably lose our atmosphere. Be much more likely to lose the atmosphere. And either way, you're not going to have life.
So,
at least as we understand it.
You know, Elon Musk is talking about putting people on Mars, and that gravity is way different from Earth's. Not maybe like Jupiter would be, but that I thought about how are they going to live on a planet that the gravity is so much different.
Well, we managed to walk on the moon.
Yeah.
And I suppose, there is still significant gravity on Mars, and it's just that everything would weigh less. Same mass, but it would weigh less because the gravitational attraction. But I don't know if we're going to get to Mars. We'll see about that.
Yeah.
I remember going to NASA in Houston and listening to John Young, who was one of the moonwalkers. And he was talking at that time, 1997. He was telling us how we were going to get to Mars, how we were going to do this. And they had these grand ideas. Well, we haven't done it yet. I don't know if we're going to do it. That's a really tough thing to get to Mars and keep people alive. And maybe we'll do it. We'll see. But I think you could still do it because there is gravity. It's just not as strong.
Yep. Our bodies would well, of course, those astronauts that just returned, they were in space for a year, weren't they?
Yeah, they
And
were up there a long time,
uh,
and they do exercise and they do things like that.
mhm.
But still, you're going to lose bone density, muscle mass, things like that, at least to some extent. But they can do things to try to alleviate those problems.
So
They might be able to overcome that.
with generations on Mars, if that ever did happen, generations on Mars and generations on Earth, do you think that the two populations would come to differ in 1,000 years or something like that?
Oh, I think the longer you go, certainly that would be true. What you would experience there is what is called a founder effect in genetics. Is that if you take a small population of any kind of organism and you place them separate from the larger population and allow them to reproduce, that over time they're probably going to have some fundamental differences based on the gene pool that they started with. It would take a long time to determine any kind of significant difference, but it could happen.
And there, I think, is where I want to kind of jump off and get into the topic at hand. You said a long time, and
Yeah.
we think about the age of the Earth and the controversy, maybe, uh, but
And
also,
I don't like to think of it as a controversy. I know people argue about it all the time, and it's fun to think about. I go back to Genesis, and Genesis tells me that in the beginning God created. That is all I need, right? In the beginning, God created. Now we can argue about how He created. We can argue about when He created. How old is the Earth? Does evolution have a fundamental part of how life came to be as we know it? And those are good questions and fun to talk about. I've been out to the Grand Canyon, and I've been in the Colorado River looking up at the walls, and you can see some really cool things. One of which is layers of rock that are bent but not broken. And you can find these pictures on the internet, I'm sure. But what it tells me is that these fairly thick layers of rock were not solid when the bending took place, because with geology, bending takes place all the time. Forces of movement take place all the time. So to look at that and think, well, we might say that those layers of rock represent hundreds of thousands or millions of years. And we know that they don't, because they're all bent all together. They were not rock. They were not solid. They became solid later. So there are some things like that which would suggest to me that there's a young Earth. And there's so many other, there are many things that would support the idea of a young Earth. And if you really want to go see what they're, look at Answers in Genesis, and they'll tell you all that. On the other hand, you can go and talk about things like the Big Bang cosmology, and you can look at radioactive decay rates, and you can look at the fossil record, and you can see that things have changed over time. Maybe not in the way Darwin would have expected, but you can see that life has changed over time. You can also look at the Big Bang and say, some Christians, I would think, would not want to talk about the Big Bang, because then it seems to assure that you have long ages, 14 billion years or something to that effect. And they would say then that is not what the Bible says, because the Bible says it's like 6,000 years old. And I don't know how to make those fit. I have my own ideas, but it seems like that's where people argue, and that's why people don't want to have an old Earth, or they don't want to have a young Earth because of their religious views, or because they don't like Big Bang, they don't like evolution, whatever it is. If we try to just look at the facts, then we can think about it more clearly, and that's what I try to do. I'm sure I'm certainly biased, just like everybody else is.
Well,
But
I
I
read,
think that we should not base our faith on the age of the Earth. Now, some people would disagree with that, but I think God created or God did not create. That's the question.
yeah. You mentioned a few moments ago about the shifting of the tectonic plates,
Yeah.
and that has enabled us to have life, or part of the ingredients that were necessary, I think. But and as we measure the movement of the continents that's taking place currently, I don't know, it's very, very infinitesimal. And so if they've always moved at that rate, then it's taken them a long time to get where they are, right?
Yeah. And that would argue for an older Earth than many people would like to say.
Or they could
And,
have been,
and one of a lot of people look for a long time. They looked at the western coast of Africa and the eastern coast of South America seem to fit together like a puzzle. And when we start to look at the movement of tectonic plates, some of that begins to gel and seems to make sense. You go all the way back to things like Pangea, when the land masses were more connected than they are now. So we've got to take that into account when we think about our view of the age of the Earth.
so you said when they were all connected, and we can think about the different, how did people get from Asia across Alaska? I learned that a long time ago, but and
Well, that may or may not be
may
true.
or may not
There's
be
arguments
true,
about that too,
but maybe they
and
all
that would
just
have.
started together.
Well, I think the time frame is a lot different there, though. When
Yeah.
people are talking about the land bridge across the Bering Strait, much, much later than you would have had Pangea or uh, um, Gondwana land and Laurasia. That's much, much further in the past.
Yeah,
And then how humans got to North America. There have been so many books written about that too. Very interesting.
so we do have human beings though. And
Well, as I know, you and I are
yeah,
two of
that's
those.
right. Whew. I read somewhere that, and read it again, that there was a common Eve to all humanity. And from there, everybody has come into existence. Is that true?
Well, okay, we read the Bible and we have Eve, right? We have
Yeah,
Adam and
well,
Eve.
yeah, when I say Eve, then
And
I'm
then you go to the
symbolically.
geneticists and they talk about what is called mitochondrial Eve. Mitochondria are the powerhouses of the cell. Inside of each of our cells, we have, well, yeah, inside of each of our cells, we have mitochondria. And you look at those mitochondria and you can find that they have their own DNA. So, besides the 46 chromosomes we like to talk about in the nucleus, there is another source of DNA in each of our cells. And almost entirely, exclusively, the DNA in mitochondria comes from our mom. So you can follow the maternal lineages of anyone if you can find the mitochondrial DNA. And so what the geneticists have done is they've looked at the differences, the mutations that have accumulated over time in the mitochondrial DNA, not the nuclear DNA, because then we can be just looking at what mom gave us and what her mom gave her and all the way back. And ultimately the geneticists arrive at something where all or most of humanity has been derived from one or a few women. They don't claim that that was the first woman. They claim that you can follow that ancestry back to there. But then they would not, the geneticists would not equate that Eve, whom they would suggest came out of Africa, mostly what they would suggest that. They would not equate that Eve with the Eve of Genesis. And so it's an interesting phenomenon. And you could follow the Y chromosomes in the nucleus and follow paternal lineages. So you can follow that back. In fact, some of those Y chromosomes have been used to determine whether the current priests in Israel are actually derived from Levites. And I read something about that a long time ago. I'm not sure what I think they determined that they are, but I can't remember. But that's the Y chromosome. You can follow to paternal lineage, and the mitochondrial chromosomes you can follow to maternal lineages.
Where does in talking about all this, our minds go to, and I think you've already mentioned the name Darwin. Where does that fit in all this?
Oh, that's a big question, isn't it?
Do you have like 24 hours or?
Oh my goodness. So, all right. When we talk about Darwin, we go back to the early 1800s. He published his famous book on the origin of species in 1859. So he had been on the voyage on the Beagle. Earlier in the century, he thought about it, wrote some things, finally was kind of pressured into producing this volume in 1859. I think he originally intended it to be much longer, but it was long enough. And from that point on, people started thinking more about, if species can evolve, which Aristotle thought they could evolve. He just had no mechanism, no clue about how they could evolve. Darwin suggested a mechanism, which we call natural selection. There's variability in populations. The different environmental influences can affect how well genes can be passed on into the next generation. Of course, Darwin didn't know anything about genes, but he knew about traits. He knew about ideas. And from that time on, we had a mechanism that is, Darwin was a genius. No matter what people think about his ideas, he was a genius to think about and write down these ideas in the way he did. And if you want to read his book, there's a lot of tedium in there. It's Victorian prose. It's hard to read, especially for a non-biologist. But, it's at some point, maybe it's worth picking out a chapter or two out of his book and just trying to do it and see what he said. But that brought about a mechanism for evolution. Well, evolution is just change over time. We know things change over time. Population, and you subject it to different kinds of pressures, such as different nutrients, you'll see differences in the gene pool within those bacterial populations. We know that if you take crickets and you isolate one group of crickets from another, over time, you'll end up with two different kinds of crickets. Now, depending on how much time, are they separate species? Maybe, maybe not. And that's evolution. If I go to the Creation Museum in Kentucky, they will say, yeah, we've observed evolution. We know about evolution, but only at that small scale. And I think most biologists would agree that evolution occurs at a smaller scale, what we call microevolution. Now, the question really that Darwin raised is, how do we get birds? How do we get feathers? How do we get bones that have pneumatic air spaces in them? How do we get a supracoracoideus muscle, which is this, a muscle? You eat turkey for Thanksgiving?
Yeah, sure.
White meat or dark meat?
I eat.
You like the white meat?
Dark meat.
You eat the dark meat? If you eat the chest muscles, some of those muscles are pectoralis muscles, but some of them are supracoracoideus muscles, which then will go up over the skeleton and go out to the humerus so that they can lift the wing. If I want to lift my wing, if I want to pull my arms back, I will use back muscles and they'll just pull directly across the shoulder. But for birds, the muscles the bulk of the muscle is down here on the ventral side of their body, so that lowers their center of gravity and helps them to fly. And where do you get something like that? Those are the major changes. Warm-bloodedness versus cold-bloodedness. Four limbs versus no limbs. I mean, what's the difference between a sponge, which is an animal, and a horse? There's so many differences in between them. And we have to think about, where do the major changes take place? And Darwin would suggest that, well, they take place over time, given enough time. Now, Darwin thought the Earth was probably about 1 million years old. Later on, we changed our ideas. But fundamentally, a long period of time. And so what we would expect is that slowly over time, you see gradual changes, and you see gradual accumulation of mutations, which are advantageous for that organism in that environment. And some of that we can see, some of that in the microevolutionary area right now, we can see organisms adapt to their environment, but usually that is because they lose some function, not gain some function. They haven't gained some kind of new structure. So the fundamental question is, can we create new structures to make a horse and a fly and a squid? Can we create all of those using genetics over time by random variations and natural selection? And there's a book sitting right here called Genetic Entropy and the Mystery of the Genome. I don't know if you can see that, by J.C. Sanford, a former prof at Cornell. And he would say, no, we don't have enough time to accumulate those. One of the sticking points is every mutation has to have some advantage if it's going to be retained within that population. Well, a lot of these mutations would take place with no advantage until the entire structure is present. You've got so many genes that contribute to the feathers of a bird. You've got to have all those genes present, or at least most of them present, in order to make a fundamental feather, right? And that feather doesn't have a whole lot of function until you get something significant. That's where I think one of the fundamental problems lies. The genetics, the rate at which mutations can take place, and will be argued by people like Michael Behe. Michael Behe has written books about the rate of mutational change and how it can be selected, how fast it can be selected, and would argue that we do not have enough time on the Earth for the number of mutations to have accumulated for us to explain the way life is today.
So was Darwin right or wrong then?
Yes. And no. Darwin was right in some ways, and he was wrong in other ways, some of which we don't even know whether he was right or not. But certainly he was describing things before genetics. We didn't know much about genetics at all until about 1900. He was writing in the middle of the 19th century, so he didn't know anything about genetics. Didn't know what DNA. Well, DNA was actually discovered 10 years after his book was published, but it didn't tell us much. We didn't know what it was until the 1950s. We didn't really know what made it up, how it contributed to genetics. And then we've had an explosion of information about that. Human Genome Project, the ENCODE project, trying to describe how the genome works. We understand a lot, but there's still a lot of mysteries about the genome. But was Darwin right? Certainly in some aspects he was, but in the greater aspects, I'm not sure that he was.
Hi, I'm Amy. Are you ready to take the next step in your faith journey? Start Climbing with Mark is a short but powerful booklet designed to help you grow in Christ. The 16 devotions from the Gospel of Mark will help you attain, maintain, and regain spiritual momentum. Whether you're just starting out or looking for a fresh start or seeking to encourage a friend in their faith, this resource is for you. Order your copy today at momentumministries.org and let's start climbing together.
Let's curve this discussion about evolution toward intelligent design, okay?
Okay. I think we already have.
Yeah, okay. Well, then say explicitly what you've said implicitly so far.
Well, intelligent design, if you go to go to Seattle, Washington, to a place called the Discovery Institute. Discovery Institute is a think tank. There's a fundamental place where these intelligent ideas come together. And there are various people there, like Stephen Meyer, Michael Behe, Jonathan Wells, who passed away recently. But they've put together these ideas about what is called intelligent design. Intelligent design simply says that there's some fundamental aspects of life, some fundamental aspects of the universe, of the earth, that the best explanation for their existence is some kind of intelligence. Now, that doesn't mean that everything that we see can be explained by intelligent design. Some things don't need that. Some things it's not clear. But one of the things that Michael Behe came up with was the idea of irreducible complexity. So that if he looked at the bacterial flagellum in a bacterium in your body, living inside your body, if he looked at the bacterial flagellum, it is composed of, I think the number now is about 40 some proteins. And these proteins must be present in the right amounts at the right times and be assembled in the right order and put in the right place. And each one of these proteins is made up of many amino acids. And amino acids, there are 20 of them. So if you have a protein made of 100 amino acids, which is a very small protein, then if you wanted to put one of those together, for every one of those 100 spots that you're assembling this, you've got 20 choices of amino acids to put in there. And so the number of different kinds of proteins you could make, according to that, is greater than the number of atoms in the universe. Those kinds of things are not going to come about randomly, especially when you need multiple proteins. And here's another one. Where are proteins made? They're made in a little structure in the cell called the ribosome. Okay, so you need DNA to give you the recipe to make RNA, which goes to the ribosome and is read out to make the protein. So, and if you want to make proteins, you need DNA, RNA, and amino acids to make the proteins in the proper ways. What is a ribosome? The place where this is built. Ribosomes in bacterial cells are made up of about 50 different proteins. Wait a minute, where'd they come from? How do you make proteins on a ribosome? What's the ribosome made of? Proteins. It has some RNAs in it as well. How do you assemble a ribosome out of all those proteins when you can't make proteins because you don't have a ribosome? Chicken and egg hypothesis, right? Chicken and egg ideas. We do not understand how a ribosome could come about to make the structures that make up the cell that allow that cell to function. Proteins are the fundamental workhorses of our body. Okay, you've got skin. If I take away one protein called collagen, your skin will fall apart. You'll have scurvy. Your teeth will fall out. You'll bleed out because your skin will fall apart, right? That's one protein. If I take away the globin proteins in your red blood cells, you won't be able to carry oxygen around your body and you have some trouble, right?
Right. Yeah.
Those are just two of the many thousands of different proteins that make our bodies work. How are they made? On ribosomes. Where did that ribosome come from? And the ribosomes in bacterial cells, fundamentally the same, but different kinds of proteins and RNAs from what we find in our cells. So same function, same general structure, but the specifics are different. How did they change? We don't know.
So
those are just some of the ideas of the best explanation for a ribosome, presence of a ribosome, and the assembly of proteins at this point in our understanding is intelligence. Now,
Somebody,
a lot of scientists would argue against that vehemently and would hate what I'm saying. But that's what I would say. That's what the intelligent design folks would say.
so when it from a Judeo-Christian perspective, God created, he was the one that made those ribosomes so that they could continue to make proteins.
From a Judeo-Christian perspective, and if God is real, as you and I believe he is, then yes. How he did that, when he did that, I don't know. I don't know.
He took the dust of the earth, whatever that is, right?
Yeah.
And he formed the man, he breathed life
Right.
into it.
And
That is a very complex, according to what you're describing, a very complex procedure.
oh my
It
goodness.
wasn't
Yeah.
modeling clay, like a 3-year-old in Play-Doh. There's an infinite amount of decisions that had to have been made, or things that had to be in place for this whole thing to work together.
And then we've got our brain. It's the most complicated machine in the universe, as we know, as the human brain, right? But you are not your brain. You are a person, right? I am a person with a personality. I have a soul. I have a spirit. I am spirit. Jim Caviezel, I think I got that. Jim Caviezel played Jesus in The Passion of the Christ. I think that's right. I think it's Jim Caviezel. I heard him talking about the scenes where he was on the cross. They were brutal for him. When they were acting out the scourging, one of them tore into his back and ripped. He still got a scar on his back from that. He was up there he was bleeding, and it was real blood. He was hypothermic. He got struck by lightning twice on the cross in filming of the movie, had 2 surgeries afterwards, almost died. In fact, he says he did die. He said he observed what they were doing in the operating room. He was up above somewhere watching what they were doing. And then at one point they got his heart going again, and he was slammed back into his body, and the pain came back. Many, many people have described that same sort of thing. Near-death experiences, when people seemingly die and their heart stops, and then they come back and are revived, and they explain what happened. You hear that over and over again. The spirit, the soul of our self is not the same as our brain. It can live outside of our brain. Normally it doesn't, but in those circumstances, that's just amazing to me. But it tells me that God had to create spirit as well as substance, right? The material part of my body is not who I am. It's where I live right now. But there is a spiritual side of life that we cannot deny.
And where did that come from? That came from the source of life. So we're going to have to probably close this up. And I hate that because we're just getting started. But
Well,
Bruce, you need to just say, I'll come back. We'll finish
I'll come back.
We'll finish
I'll come
this
back when you want
discussion
me.
later. Before we go, with what we've talked about today, the just right conditions, and we didn't even get to how that, the universe is fine-tuned. We opened with that, but we didn't really unpack it. Maybe we could come back and do that. But with what we've talked about today, with Darwinism and the age of the universe and the conditions present in the cell, what is one thing that you would say to our listeners to encourage them or to help them in this thing called life?
I think one of the things that I have done over the years, I remember back when I was in college, and then when I was in graduate school, and asking some people, what do you do with Darwinism? What do you do with the origin of life and age? I had questions that I didn't understand how to fit that all into my worldview. And so I asked several people that I trusted and got different answers. And over time, I have read, I've listened to, I've had discussions with many people, many ideas out of books and papers. I would encourage anybody to go get a few books in an area you're interested in and just read up on them. Some of the ideas that we learned in school were very much naturalistic and didn't even allow other ideas into the picture. I mean, I would suggest if things like intelligent design, if it's a bunch of baloney, go read a book and then tell me it's a bunch of baloney. Go get some ideas, go read some papers, go talk to some people, then tell me it's a bunch of baloney. And then we can have a discussion. But people who say, well, I can't believe that because that's just stupid or something like that, anything like that, they better have some background to understand what the argument is before they would say something like that. And I wouldn't say something. I wouldn't go and tell you your argument is stupid. I would say, you're making an argument. Let's talk about why I think it's not the right way to look at it. But you've got to be respectful to people's ideas. You gotta understand where they're coming from, and maybe that's what I would say.
Read and be open.
Yeah, I think that's good.
All right. Well, we're gonna stop it right there because we've passed our time that we normally go. But I want to thank you, and before we go, I want to pray. So
Let's do that.
Let's do that. Yes, Father in heaven, we don't even know where heaven is. This conversation that we've had today, we've talked about tectonic plates and we've talked about cosmology. And when we address you, we think about heaven. That's an arena of existence that goes beyond some of this conversation that we've had. But that's because you dwell, the scripture says, you dwell in unapproachable light. And we can't understand everything about you. But Lord, we can look at your creation and realize that we are fearfully and wonderfully made, both body and spirit. We thank you for that. Too often when we read that, we just think about our bodies, and they are miracles. But we have a spirit within that goes beyond the physical, and it's the part that can know you and the part that lives forever. It's not made up of finite cells and molecules and atoms. Help us to be connected to you through Jesus Christ, your Son, who himself took on flesh and died on the cross and rose again, that we might know you, that we might have life. Thank you for Dr. Bruce and for his message to us today. May it spark faith, inquisitiveness, a desire to learn and understand in each one of us. And may Christ be honored through it all. Amen.
Amen.
Well, thank you, Bruce. I appreciate you being on with us today. And
Thanks, Scott.
I'm going to look at my calendar and send you another date. So
okay.
I've got some stuff down here that we haven't gotten to. So we'll get to it if you're willing to come back on sometime.
Oh yeah. Oh yeah.
All
and
right.
later this afternoon, I need to go do a dinosaur show for some.
Yeah, I love that dinosaur.
I'm a dinosaur shirt on.
Yeah, that's amazing. we didn't talk about that yet. We'll get to it.
Sounds good.
All right. Well, God bless you, and God bless our listeners, and thank you for joining today's Casual Conversation.
Thanks for listening in on Casual Conversations by Momentum Ministries. Check out our website at momentumministries.org, where you will find books and other resources to help you attain, maintain, and regain spiritual momentum. God bless you and have a great day.